All right, so let's look at verifying these identities. I'm going to do this problem number one, I think, two different ways because I can see how to do it in two different ways. Um, if I uh, if I determine that the left-hand side is the more complicated expression, and if I start with it, I could break up this fraction into two fractions. Now, sometimes, that's going the opposite way of what we really want to do because we have a single term over here, but watch what could happen. So each term in the numerator gets divided by this cosecant squared of x in the denominator. Well, in the first term here we have 1, and by my reciprocal relationship, 1 over cosecant is the sine, and since this is cosecant squared, we'll make this sine squared. And by the Pythagorean theorem, 1 minus sine squared is cosine squared, and we're done. That's the right-hand side. We started with the left-hand side, and we split the one fraction into two, took the two terms and combined it into one term by the Pythagorean identity. So let's do this a second way. Also by those Pythagorean identities, if I have that sine squared of x plus cosine squared of x is equal to 1, if I divide everybody by the sine squared of x, I'll have 1 plus cotangent squared of x, and this will be cosecant squared of x. So cosecant minus 1 is equal to the cotangent squared. So if I start with the left-hand side, I know that I can change that left-hand side to be the numerator to be cotangent squared, and the denominator cosecant squared of x. I can write this single fraction as the multiplication of two fractions. And cotangent is cosine of x divided by sine of x, but since it's squared, we'll make it cosine squared and sine squared. 1 over cosecant squared, well, that's equal to sine squared because they're reciprocals of each other. And this factor in the denominator cancels with that factor in the numerator. And we have cosine squared, which is the right-hand side. So two different ways to do the same problem. Let's take a look at this next one. So the left-hand side to me looks to be clearly more complicated than the right-hand side. I'm going to start with it. And I have two terms on the left-hand side. Terms are separated by addition and subtraction. On the right-hand side, I have just a single term. It has these factors, but it's a single term. So I want to add these two subtract these two fractions. So I need a common denominator. So I'm going to multiply each of these terms by 1. But only I'm going to be clever in how I write the number 1. This is missing a 1 plus sine of x. So the numerator and denominator are the same. So I know that's 1, and I'm not changing the magnitude of this term. And over here, the same idea. 1 minus the sine of x. That's what this denominator is missing. So now the denominators are the same except for the order of multiplication. And it doesn't matter whether we have 1 minus sine first and then 1 plus sine, or if you do that multiplication in the reverse order. Now the operation in the numerator, it's subtraction. 1 times this, hey, we have this 1 plus sine of x. And now we're subtracting, and be careful, we're subtracting both the entire thing, not just our favorite term. So let's look and see what we get here. When this 1 minus sine of x times 1 plus sine of x is a minus b times a plus b, which is a squared minus b squared. 1 squared minus sine squared of x. Now up here, we've got 1 minus 1, and that cancels. And when you subtract a negative sine of x, that becomes positive. So we have 2 sine of x. So 1 minus sine squared of x by the Pythagorean identity is cosine squared. So we've got a numerator of 2 times the sine of x times, or divided by, cosine squared. Well, we can split up. We can write this factor of 2 there. We can multiply that times the sine of x over a single factor of cosine, and we can put a 1 over cosine x, because if you multiply all these numerators together, you get 2 sine of x. Multiply these denominators, you get cosine squared. So sine of x divided by cosine of x is by the quotient identity. That's the tangent of x, and that's being multiplied. 1 over cosine by the reciprocal identity is the secant of x. And that's what we have up here on the right hand side. So we're done. So it's given us a hint, but it's not telling us which side of the equation to use that hint on. Well, remember that the idea of a conjugate. The sine of x plus 1 times the sine of x plus 1 is not really going to get us anything, at least not one of the identities. But sine of x minus 1 times sine of x plus 1, that's going to go somewhere. So if we use the left-hand side, and if we have the sine of x minus 1 over the cosine of x, if we multiply this by the number 1, but we write 1 as the conjugate of this numerator, sine of x plus 1. See, conjugates, a plus b and a minus b, are what they refer to as conjugates. And that multiplies to a squared minus b squared. And that's very convenient for us. Alright, sine of x plus 1. Now, we've got the cosine of x times this binomial. I'm not going to distribute it yet, because if I look at this denominator, I've got a sine of x plus 1 here. I've got a sine of x plus 1 here. What I'm hoping is that cosine of x will cancel with something in the numerator. Well, it does, because when we multiply these conjugates together, we get sine squared of x minus 1. And now, I was going to say, that's the wrong order of subtraction, but hey, look at that negative sign. I didn't see that. If I want to replace this with cosine squared, I'm going to have to factor out a negative 1. If I factor out a negative 1, then that changes to 1 minus sine squared of x. So I'm not multiplying by 1. I mean, negative 1. I am in a sense, but I can't just come in and multiply a fraction by negative 1, but I can factor out a negative 1 from both of these terms. So now I have cosine of x and sine of x plus 1. And now in the numerator, the 1 minus sine squared, hey, that's cosine squared of x. And I have a factor of cosine of x in the denominator. So we can put that negative 1 just as a negative sign out in front of the fraction. Since it's cosine squared, that's cosine times cosine. Well, that's going to cancel with a factor of cosine in the denominator. So instead of having cosine squared, we're just going to have cosine, because the other factor of cosine is going to cancel with this one. And in the denominator, I have the sine of x plus 1. So that's what we have on the right-hand side. So we're done. Now, boy, on this one, I guess you could really start out on either side, because how are you going to claim that one side is more complicated than the other? Boy, if that were sine squared plus cosine squared, I'd gravitate towards it. We do have a double angle formula, but that's not going to get me. You know, I'm actually going to start with the left-hand side and see if by factoring, or if by changing that to secant squared, Let's start with the left-hand side. I don't remember how to do this one exactly, so let's see if we can figure it out together. So if I start with the left-hand side, then 1 plus tangent squared. Well, one of our guidelines says to convert things to sines and cosines. So let's write tangent of sine of x divided by cosine of x. And since it's being squared, we want sine squared and cosine squared. In the denominator, let's do the same thing. So now we've got this in terms of sines and cosines. This looks promising. All right, now it's a complex fraction, and I don't really want a complex fraction. Over here, it's not a complex fraction. Let's multiply by the number 1. But let's be clever in how we write 1. Look at this denominator. It has the same denominator down here. So why not multiply this by cosine squared of x over cosine squared of x? What's going to happen? Well, we need to multiply these numerators together. So on the left here in the numerator, I've got a binomial. Both terms get multiplied by cosine squared of x. When I multiply it times the first term, hey, 1 times cosine squared of x, that's just cosine squared of x, plus, look what happens when you take this sine squared of x over cosine squared of x and multiply it by cosine squared. This guy and this guy divide to 1. Now, let's come in and take cosine squared and multiply it times each term. When we multiply that times the first term, we just have 1 cosine squared of x. Now we have minus this fraction. It gets multiplied by the cosine squared of x. So this cosine squared of x and this guy, they cancel. This is in the numerator, and that's in the denominator of this denominator. Alright, so let's see if we can shrink this up and see what we have here. In the numerator, we have cosine squared of x plus sine squared of x. Hey, by the Pythagorean identity, that numerator is equal to 1. And down here in my denominator, I've got cosine squared of x minus sine squared of x. And we are done, because that numerator by the Pythagorean identity is 1. And this is the correct order of subtraction that's in the denominator up there. And so this guy is equal to the right-hand side. And we're done. Let's take a look here. So, which side is more complicated? Well, I would start with the left-hand side because it's going to be easier for me to condense this from two terms to a single term. The hint is telling me to factor out a sine squared. So, I don't factor it out if it's already in factors, but here, with two terms, I'd like to somehow rewrite this so that each term has a common sine squared to each term. Well, let's start with the left-hand side. And let's rewrite tangent as sine of x divided by the cosine of x. But since it's tangent squared, we want sine squared of x and cosine squared of x is that first term. And in the second term, we've got sine squared of x divided by 1. Well, now let's see if that hint they gave us is going to pan out to anything. We see these two terms and they have something in common. That they both have a numerator of sine squared. So we can factor out that common factor. And what we have left in the first term here is 1 over cosine squared minus 1. Alright, so let's leave this sine squared of x alone. And we have a reciprocal relationship that 1 over cosine is the same thing as secant. And since it's cosine squared, this will be secant squared minus 1. And we have a Pythagorean identity that tells us that tangent squared of x plus 1 is equal to secant squared of x. So if we move that 1 to the other side, what we have here is sine squared of x. And we can replace this guy with tangent squared. Because if we subtract 1, then this is times tangent squared of x, which is what we have on the right side except for the order of multiplication. It doesn't matter whether the multiplication is commutative. Tangent squared times sine squared is the same thing as sine squared times tangent squared. So that's the right-hand side, and we're done. Alright, so let's take a look at this. Alright. I believe that it's easier for students to combine two terms to a single term. So I'm going to start with this left-hand side. And one of the common things that they tell us to do is to rewrite everything in terms of sines and cosines. So if I start with the left-hand side, and I rewrite cosecant of x to be 1 over the sine of x, and cotangent of x is the cosine of x divided by the sine of x. Hey, these have the same denominator, so I can write these as a single fraction, and I've got 1 plus cosine of x. Now, it's often the case, at first you think it's a trick, but when you start using it multiple times, we've seen before that we had a situation where the hint was to multiply by the conjugate. This 1 plus cosine, I'm going to multiply by 1 minus cosine. And if I put that in the denominator, I'm actually multiplying by the number 1. and that's not going to change my value here. So in the denominator, I'm not going to distribute it yet. I might later. But if I look at this, I have 1 minus cosine here, and I have a 1 minus cosine here. And hey, I'm hoping that sign is going to cancel. Well, up here, when I have a plus b times a minus b, this multiplies to a squared minus b squared. And that's the Pythagorean. That I can replace with sine squared. So since sine squared is sine times sine, one of those factors of sine is going to cancel with the factor of sine in the denominator, and we get that right-hand side. We have one of this is squared. Well, one factor cancels with that one, and we have the sine of x divided by 1 minus cosine of x. That's the right-hand side, and we're done. So I hope that helps. Is that the last one? Hey, that's the last one. Talk to you later.